2 people on there. Have you been on there yet? 3 people. Oh. Alright, guys. Any questions? 4 people in here. What are you doing? Hey. Hey. What are you doing? Oh. He doesn't want to be held. He just wants to stand there. He just wants to look at people.
Here. Ooh, come on.
Anybody got questions?
This is super late.
Wow. I might have to go dig and find that question. Yeah. Yeah, give me a second. That's just not super late. That's super duper late. Ugh. It's a he. Alrighty. So, we have a square. And on the square, each side represents something. 1/3 y plus 5. Negative x plus 9. Negative 3y plus 15. And then x plus 3. Okay, so with this, parts of properties of a square is that all sides are congruent, and it wants to know what values of x and y are going to make this a square, or at least a parallelogram. And what we're going to do is we're going to use the idea the opposite sides are parallel to set up an algebra equation. So here I have y, so I can be able to solve for y's, and here I have x's. Let's do the x's first. We have negative x plus 9 is congruent to the opposite side. Congruent is an equal sign in algebra. Comes x plus 3. From here, we're going to subtract x from both sides. And we've got a negative 2x plus 9 equals 3. We're going to subtract 9 from both sides. We have a negative 2x equals a negative 6. We're going to divide by negative 2. And x equals 3. All right, so we know x equals 3. And
oh, sorry, question. X equals.
Yes.
Sorry, my bad. From square one, saying.
Yeah. Let me put question 2.
I know, but then he's saying like right after.
No, that's fine. This newspaper is thicker, but it rips so much easier. Yeah, like when it goes, that's why it's hard to erase. It's weird. The thinner stuff, it doesn't rip as much. I don't know. All right, 1B. We basically want to know if it's a rectangle, rhombus, or a square. I have point A, which is a little high, so I'll drop it down a little bit, which is -2, 7. We have point B, which is 7, 2. We have point C, which is -2, -3. And then we have point D, which is -11, 2. Okay. All right, so we want to figure out, is this a rectangle, rhombus, or square? That's what the question actually asks. The first thing we need to do is we need to check, is it one of those three, which it will be, but we need to check it anyway to see if it's a parallelogram. So what I want to do is I want to check the slopes. Yeah, let's do the slopes first. All right, so what I need to do is let's do a rough sketch. And I've got -2, 7. This is going to be A, 7. Yeah, 7, 2. This is going to be B, -2, -3. This is C, and then -11 and 2. This is D. So we'll sketch it out. Of course, this is not to scale. This just gives me an idea of what sides go together. So I'm going to look at this. I need to have the slope of AD has to equal the slope of BC. And then the slope of DC has to equal the slope of AB. Okay. So this has to be true. If that's true, we at least know it's a parallelogram, and from there we can actually see if it's going to be a square or a rectangle, and I'll show you that in a second. And then from there we'll have one other step to determine if it's a square or a rectangle. All right, so from here we need to know my slope formula. My slope formula is y equal, not y. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so we're going to use that formula. So here we go. Slope of AD. So let's look. 2 minus 7. 2 minus 7 over -11 minus a -2. This gives me a -5. No, if it's not a parallelogram, it can't be a square. A square is a parallelogram. It's a special parallelogram. And then this becomes plus, so what is that? -9, so this becomes 5, 9. Okay, that's easy enough. So from here, we got the slope of AD. Let's do the slope of BC. So let's do this. -3 minus 2. -3 minus 2. And -2 minus 7 gives me a -5 over a -9, which is 5 9ths. Okay, cool. This is true. Check. Those opposite sides are parallel because the slopes are exactly the same. All right, slope of DC. So 2 minus a -3, 2 minus a -3 over DC. -11 minus a -2. This gives me a -5 over -9. That can't be. Can't have the same slope. 2 minus a -3. Oh, this is plus 1. No, it's just 5. There we go. I was like, it can't be. So that's a -5 over 9. And then the slope of AB. So we got 2 minus 7. 2 minus 7 over 7 minus a negative 2. 7 minus a negative 2. Something's wrong here. Gives me negative 5 and gives me 9. No, that's good. So those are parallel. Perfect. Now, I can already tell these are not a square or a rhombus. Being a square or a rectangle. The way I can tell that is I'm looking at my intersecting lines, AD and DC. For it to be a square or a rectangle, it has to be 90 degrees, meaning that they're perpendicular. If they were perpendicular, the slope of this would be flipped upside down, and it would be the opposite sign. Well, it has the opposite sign, that's good, but this isn't flipped upside down. It should be 9/5. Instead, it's 5/9. It's the same number, just with the sign change. So they're not perpendicular, so they can't form 90-degree angle. So now we just need to check to see if it's a rhombus. Well, rhombus is easy enough because we're just going to use my distance formula. My distance is the square root. Yeah, it's going to be a rhombus. Do you need to see me finish it out? My x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared.
No, you don't have to finish.
Cool. If you want to see it finished out, you can actually go to the live stream on 4/22. In the description, I'll have a time with the entire problem worked out. Problem 1 of this week's work. Algebra 2. Yeah, Tori, I'll do that. Is there a particular method you want me to show you? You want me to show elimination or substitution? So that it's my choice. I'm going to do it the way I like to do it. You're welcome. Or is there a method you want to see? First Algebra 2 question in like almost 2 weeks. Okay, so we have a system of nonlinear equations. So we have x squared minus x squared equals 4, and then x plus y equals 2. All right, well, what I'm going to do is I'm going to do elimination then, seeing how you don't really care. What that means is I need to get the coefficient of one of the variables the same number, but opposite sign. So I look here, I have an x squared with the coefficient of 1. I look at my bottom equation, I don't have an x squared, so I can't do the x squared. I have an x with a coefficient of 1, but I look at my top equation, there's no x, so I can't use x. My only option to elimination on this is y, because they both have a y. Now, I look at the coefficient in front of y, and I have a negative 4. So what I need to do is I need to multiply this bottom equation by a positive 4. So this is going to give me x squared. Now I'm going to add a placeholder in here. Plus 0x minus 4y equals 4. Now I want to put a placeholder for the x squared on my second equation with a 0. So 0 times 4 is still 0x squared. Now 4 times x gives me 4x. 4 times y gives me 4y. And 4 times 2 gives me 8. All right. Now, once I've done that, if you look, my y's here, both the numbers are 4, but I have opposite signs. The reason why we want to do that is because when we do elimination, we want to add the equations together. Now, this is why I put the placeholders in there, so we have columns of everything, so we know we don't accidentally combine the wrong thing. X squared plus 0x is just x squared. 0x plus 4x is just 4x. Negative 4y plus 4y is 0. It's gone. And then 4 plus 8 will give me 12. Well, here's an equation I can solve. I can actually factor out an x, and that's going to give me x, and then x plus 4. No, I cannot factor out an x. Wow. See what happens when I wake up from a nap? To do math? I am still not fully awake. Woke up from a nap to do this. Because this isn't 0.
Oh, okay.
So this becomes x squared plus 4x, move the 12 over, minus 12 equals 0. Now this factors, should factor, 6 and 2. X plus 6, x minus 2 equals 0, 0 product property. We're going to see that x equals negative 6 and 2. Set each of these equal to 0 and solve. Alright, so now I have the values of x. I just need to find the values of y. So I want to pick one of these two equations and solve. Well, I want to do this bottom equation. I have x plus y equals 2. Well, I have two values of x. Just plug them in. Negative 6 plus y equals 2. Add 6 to both sides. I get y equals 8. So one of my solutions is going to be the point negative 6, comma 8. Alright, we're going to do it for 2. So we're going to do 2 plus y equals 2. Well, y is going to equal 0. So my other solution to this is simply going to be 2, comma 0. And you're done. That's it. Piece of cake. I didn't even write the time I started on that. I'll go back and look. At least write the date so I know I did it today. 5, 6. It ain't time to eat yet. And every problem on the sheet, Tori, is set up so you can do elimination or substitution. I set everything up. One way is going to be easier than the other. It's just from experience to figure out which one's going to be easier. I personally like elimination. If I can do elimination, I will always do elimination. Yeah, I'll do this week's number 4. And you're welcome, Tori. Well, shoot.
It's fine. Just a little.
All right, this week. Oh yeah, thanks. This week, number 4. 3. Okay, so what?
Oh man.
I really do. I really do. We have the equation y equals negative 2x minus 5. How'd you do on your final? My point is negative 4, negative 5. All right. So, to find parallel and perpendicular, you have to know the relationship between the slopes. First off, you have to be able to identify the slope. The slope of this equation, we're going to get from the slope-intercept form, which is y equals mx plus b. My m is my slope, so right here is my slope. For a line to be parallel to this line, the slope has to be the same. So my parallel slope is going to be the exact same number, negative 2. My perpendicular slope is going to be the negative reciprocal, meaning we're going to change the sign and flip it upside down. Well, this is really just 2, but we can always write it as 2 over 1. So if I change negative to positive, I don't need to write the positive, and take 2 over 1 and flip it upside down, I'll get 1 over 2. So there is my perpendicular slope. Now, to find the line that is parallel, what we're going to do is we're going to use this y equals mx plus b. Conveniently, I gave you a point with an x value and a y value. And you have an m. So we have 3 of the 4 things here, and you learn in Algebra 1, if you have everything but one variable, you can solve for that one variable. So we're going to plug it in. So y equals mx plus b. My y is -5 from my point here, equals my parallel slope, -2 times my x value from here, -4 plus b. And I'm going to solve for b. So I've got -5 equals 8 plus b. Subtract 8 from both sides, and that should be -13 equals b. All right. From there, I know my m and I know my b. I can put it into my equation. My equation always has my y and my x fixed. So my y equals my -2x plus a -13, but we don't write the plus, so we write -13. So here is my equation for parallel. All right, so for perpendicular, we basically rinse and repeat, except that what we change is the m is going to be positive 1/2. So we're going to do y equals mx plus b. My y is from my point, -5. My slope for perpendicular is here, which is 1/2 times my x value, which is -4, plus b. From here we solve for b. -5 equals, well, half of -4 is -2 plus b. We add 2 to both sides. That gives me a -3 for b. And then from there, we just write our equation. We have our m, we have our b. So therefore, we have y equals 1/2 x minus 3. And you're done. This is your parallel and your perpendicular. Piece of cake. Huh? My geometry is way different.
I get that.
I figure geometry is different now than what it was when we took it. There's less emphasis on certain things, and then I emphasize different things that most people in geometry don't.
Right. Yours is more.
Yeah, you see that?
Yeah.
That's really what geometry is used for in the modern world, is to set up some sort of analytical problem and then solve it from there. It's really cool when you start having geometry blend with calculus. But most people aren't real good at geometry, so they don't see it. I didn't see a lot of the...
I would have thought that it...
No, the x is just an x. You use the x value that you have. The only thing that changes in this type of setup is the slope. Your x and y's are exactly the same. You don't change those at all. The only thing that changes is the slope, because that's what you're changing, is parallel and perpendicular. The point doesn't change. If you change the x value from a positive to a negative, you have now changed the location of that point. Oh, well, your daughter didn't answer me. Was it French? Cool. You know who I haven't seen here? Jad. He is at Moscow on Monday. He might be there again today. Oh. Gotcha. Alright, what other questions, homies? Yeah. I just change it up. When? How much?
I don't know.
I asked you to get a quote, so
Okay,
I'll make sure I have
just-
enough cash.
Ask him. Okay. But he said was okay.
So you only need my help to hang up the ceiling fan? I can go back with you. Can you do 7 just to have an example to go on? Sure, why not? Alright, so 7's going to be at 2448. Oh, I was nowhere near as nice on this one. Change colors. Okay, so here we go. Y equals negative 2/3 x plus 2. Point P is negative 5, comma 1. I was not nice on this at all. Okay, so my slope, negative 2/3. That means my parallel slope is exactly the same thing as negative 2/3. My perpendicular slope, I'm going to change it from negative to positive. I don't need to write the positive, but I'm going to take the fraction and flip it upside down. So it becomes 3/2, and you notice the sign changes. So here's my parallel and perpendicular slope. All right, so now what we're going to do is we're going to use my x value and my y value. Those don't change. Hope you heard my dog bark because he is trying to be a pain. So x and y's don't change. I'm going to use my slopes, and my y equals mx plus b. So my y is 1. My m is, let's do parallel first. My m is negative 2/3 times my x value, which is negative 5, plus b. Gotta love trying to do this with dogs, especially when it's getting close to his feeding time. Man. All right, here we go. So we got 1 equals, when we multiply fractions, we multiply straight across. That's still a negative. So negative 2 times negative 5 is 10 over, well, 3 times 1 is 3, plus b. We're going to subtract 10/3 from both sides. So I have 1 minus 10/3 equals b. Well, 1 is easy to turn it in to get a common denominator. I just look at my denominator 3, and I just write it as 3/3 minus 10/3 equals b. 3 minus 10 is for my top, is going to give me negative 7/3 equals b. Okay, so I have my b, I have my m, I write my equation. It's going to be y equals a negative 2/3 x minus 7/3. Okay, so there's my parallel. So let's do perpendicular. Same exact stuff. 1 equals, I'm going to use my perpendicular slope to 3/2 times negative 5 plus b. We're going to solve this out. I've got 1 equals, multiply fractions, 5, the negative 5 and 3 gives me a negative 15/2 plus b. This is a negative, so I need to do the opposite, which is add. So I'm going to get 1 plus 15/2 equals b. Adding fractions with different denominators, when you have 1, just look at the other denominator and write it like so, 2/2, because that's still 1, plus 15/2 equals b. Now we just add my numerators, gives me 17/2 equals b. So my perpendicular equation is going to be y equals my slope, 3/2 x plus, because it's positive, 17/2. This one's harder only because of the arithmetic, not because of the concept. The concept's pretty basic, but the arithmetic is a lot more challenging on this one than the last one we did. All right, what else? What?
It wasn't quite down. He said sparks and pipe strings always in the street. That's when that's how he's hitting right now. You better leave it alone.
Huh?
Yes. You just look at the lights, what you think.
Oh, down here just doesn't like to erase.
Use that carpet off, dude.
Easier for me to grasp. You think? Let's try. Good job, Renee. What other questions? There wasn't that much on. Hey. I wonder how many people jumped out there when I threw it.
At least I was looking through.
That would have been great if you're on the stream because you jumped.
Oh, God.
What?
But why is Ahsoka so annoying?
Because you're jealous that you're not her.
Sorry, let me do it in her voice. Master!
You only talk like the
Master.
It was only like the first 2 seasons like that. You have to think though.
Saying Ahsoka is a have to do the quadratic formula.
Make me actually create an equation. Yeah, give me a second. It's not a new quadratic formula, it's a new method to actually solve the entire thing. His just happened to be over here. Okay. The order in which you do things, the Pythagorean theorem, Pythagorean formula, wow, I can't even think. The quadratic equation, there we go, is just a formula that you use to pop A, B, and C in to get an answer after doing arithmetic. This other way is an algorithm, which is much more intuitive, easier to understand. Most of math is algorithms. But with quadratics, there's so many different algorithms to solve. That's why we have the quadratic formula, so there's just one set formula. This is just a whole new algorithm and a way to solve it. 8, 16 makes 32. Oh, I don't want a leading coefficient. Oh, it's okay. I'll show that. 2x squared minus 12x. Nah, it's fine. It's hiding stuff over here. Okay, so we have an equation, a quadratic. 2x squared minus 12x minus 32 equals 0. Okay, so the first thing you want to do is you want to look and see, is my number in front of my x squared a 1? In this case, it's not. It's a 2. I need to turn it into a 1. So what I need to do is I need to divide 2 by 2 to get it to 1. But what I do to one item, I have to do to everything on the equation itself. Or you could think of it another way as factoring it out and dividing by 2. Either way, you're going to get the same result. So I'm going to divide everything by 2. So I can get my leading coefficient, or the number in front of my x squared, to be a 1. Well, 2 divided by 2 is 1. This gives me x squared. Is it negative? Yep. This becomes negative 12 divided by 2 is negative 6x. And then negative 32 divided by 2 is negative 16 equals 0, because 0 divided by 2 is 0. Perfect. All right, now this is based on your sum and product. Let's see if I can remember, because I haven't done this in a while and it's still new. So see if I have it committed to memory. My sum is my b, but we change the sign. So it goes from negative 6 to positive 6, and my product is my c, negative 16. Now we're going to take half of my sum, and we're going to take some random number and add half. Take half of my sum, and I'm going to add a random number to it. And I want to take half of my sum and subtract a random number to it, but they have to be the same number I'm adding and subtracting to, and that's going to equal my product. From here, I FOIL this out, and I'm going to get 9 minus u squared equals negative 16. And now I just solve for u. I'm going to subtract 9 from both sides. I got negative u squared equals negative 25. What? I'm going to change, since this is negative, I'm going to divide both sides by negative, and I've got u squared equals 25. Take the square root, and I've got u equals plus or minus the square root of 25. Therefore, u equals plus or minus 5. All right, so there's my two u's. To find my actual values, what I want to do is I want to plug them back in here. I've got 3 plus 5, which is 8. There's one answer. And then I've got 3 minus 5, which is negative 2. So my solution here, therefore, x equals negative 2 and 8. And just for a quick check, you can just plug these in and see that it works. Negative 2 squared is 4. 4 times 2 is 8, so I've got 8. Plus 24 is 32. 32 minus 32 is 0. That checks out, and 8 is going to check out as well. This to me is a lot easier than the quadratic formula. This does factor, but I actually think this is easier than factoring once you get it down. Providing these are nice, pretty numbers, this ended up being a nice, easy number. Because this was an even number, and then I could get rid of this as a 1. If not, then the arithmetic gets harder, but that's really all it is just arithmetic. The procedure's the same. I always remember that. I haven't done it in a while. Sum is your negative b. My b is negative 6. So negative b, and then your product is just c, and then you take half of your sum and add a number, half your sum and subtract a number. What he's actually doing in a parabola, you have a thing called an axis of symmetry, right? So what we're looking for is a point here and a point here. Well, this axis of symmetry, we know that these distances are the same. That's your u.
Okay.
That's your u right there. That's why you're doing a plus and a minus, because you're going from this line, you're going minus and a plus. This 3 is coming from here. That's why this actually works. Because it took me a little bit to think, why does this actually work? It's utilizing the axis of symmetry to actually solve it, which is starkly different than factoring and quadratic formula in the conceptual process of it.
Right. Quadratic is just minus.
You gotta have it memorized,
yeah.
And then you've got to know how to deal with square roots.
Mm-hmm.
I mean, this is but this is a much easier square root. And when this is completely done, when you do it correctly, this is 9 times out of 10 already fully reduced for you.
So, and the steps of that is way
by far. Yeah, it took me a little bit. Before I taught it to my students, I really had to think, why does this work, in case they ask me a question? And I was thinking, why is he saying he's adding and subtracting a random number? I says, oh, he's going from the axis of symmetry, which is a completely different conceptual way to actually solve these problems. Let's try it with the smaller one. See, easier with the smaller one. Still the same pain. See how it ripped?
Well, I know about parabolas, so I get a little mind-boggling for some find the algorithm work.
Oddly enough, Renee, this is happening almost multiple times a year. The reason why most people don't see it is because these new algorithms and procedures people are coming up with are for the higher level advanced mathematics. The people that are researching into how to make new math are working on the much higher level mathematics, trying to push the boundaries of math. This was really his job at Carnegie Mellon, was to try to explain how to teach quadratics to junior high kids, and he was just sitting there thinking, well, they're struggling with the quadratic formula, they're struggling with factoring even when a is 1, and he dove into this. I don't know how long it took him to come up with it, or if he just had an immediate light bulb moment, but He's probably had it for a couple of years and had to completely research it before before he published it. I think on the interview or the little thing, he said that he just had he was working on it and just one night just knew how to do it. Sometimes that's what happens. Your brain's working problems and then just immediately know how to do it. You know that from experience. Woke up in the middle of the night. I was stuck on a math problem in college. Woke up in the middle of the night, knew how to solve it. Got up, went and solved it at the kitchen table, and then went back to bed. Then my wife woke up, went to work, and was like, what in the world happened? Because the kitchen table had math on it with a calculator and everything else. True story, huh? Yeah, I was really excited about this because this is the first real breakthrough in probably 400 or 500 years in solving quadratics. What are you looking?
Dr. Lewis.
Is there a lot of videos now on it or no?
But he
His proof is just another way to derive the quadratic formula. Which then, if you can get to, because it's already been proven how to do a quadratic formula, that means his proof is not a proof, it's a lemma. You do a smaller proof and then another smaller proof to prove the bigger thing. But the quadratic formula has been proven out so much you don't actually have to write it. So, what other questions, guys? Dog's about to move the camera. Oh, so he did it quick. Wow.
it came out in October.
Yeah. I was wondering. The drawbridge. Yeah, I mean, I've been teaching it that way. The drawbridge analogy was the students, Mary Diaz, I think is what her login was. I never thought of it like a drawbridge, but yeah, I mean, that's how I've always taught how to add and subtract fractions. I think the first time I showed my wife that, she was like, well, blankety blank blank. What are you... Hey, what are you doing? Stop whining. Live streaming with a grumpy dog. No, he said he watched it yesterday.
If you could do the easy way to add fractions. He was on his mom's phone yesterday.
Oh.
That's why the last name's
Gotcha.
So they saw it. Yesterday's video was wondering if to add fractions of drawbridge. So
oh, you want another example of it? Alright. My dog's gonna be getting on my nerves because he's down there like whining. Alright, so we've got, let's do 3/13 minus 17/9. Okay, so to do this, we have to create a common denominator. And this one's not obvious. This is a prime number. This is a composite number. This breaks down to 3 and 3. This is 1 and 13. So there's nothing really I can do to get like an LCM or anything like that. But what you want to do is you multiply your bottoms together. 13 times 9, that's 90, and 27 should be 117. And then I'm going to multiply up going like this with my hands. Here and here. 9 times 3 is 27. Minus, bring my minus down. I'm not doing 13 and 17 in my head. 17, 221. 221. Now we just simply subtract. Do 190. I don't even know. My head. 194, negative 194. Now we have negative 194 over 117, and you're done. This doesn't reduce. No, it doesn't reduce. For a minute, I thought 117 is prime, but it's not.
You know how we did it.
Oh, yeah. Get the actual formal definition of adding and subtracting fractions. So Renee, what I'm going to do is I'm going to write up the mathematical definition of how to add and subtract fractions. So it does A over B plus C over D equals AD plus, I do plus or minus BC all over BD. This is the formal definition. You'll find this in textbooks, in math textbooks. This is how you're supposed to add and subtract fractions. No, BC. B and D is going to look funny for you because they're flopped. Okay, so this you'll find in textbooks. You can look up the proof on this. This is a fact. So let me show you how this works with my method. This little drawbridge thing that you said. So we have A over B plus or minus C over D. I'm going to show you why this works. We multiply the bottoms together. Well, B times D is just BD. All right. Now, we multiply up like the drawbridge, right? I'm going to use different colors to denote different things. So D times A, because of commutative property, I can write it as, I can do AD. Now I have my plus or minus because I bring my sign over. Now B times C gives me BC. If you look, doing this right here results in the exact same equation as what you'll find published in textbooks. So it'll always work. It'll always work. This is just a good, easy way for you to memorize this. So instead of you just having to memorize a formula, by learning to do this, you have this memorized. So I don't know. I don't know why teachers, why they don't.
I didn't know.
Like this?
Yeah, I never saw fractions that way. I always did the find the denominator, sometimes by multiplying the bottoms. But multiply to get to that opposite. You know what I'm saying?
Yeah. Well, I didn't see this till, I forget which class I saw that in.
Yeah, because they always had us like write like the fraction here and then here, and then multiply the bottoms together to get your denominator.
Oh, I can tell you why that happens that way. I'll tell you exactly why it happens that way. And I'm going to preface this because this is open for everybody to see. Elementary school teachers, I wouldn't want to do it. Really, really hard job. They have to do a lot of different things for different subjects. However, when they teach fractions in math, one, they're probably more than likely they don't enjoy math. So unintentionally, they put these math anxieties in it. But they teach fractions the way they were taught.
Right.
And there's nothing wrong with it. It's just the hard way. They're teaching fractions the hardest possible way to do it because they haven't had the upper level class, so you start seeing how to do stuff like this.
Also, like, in fraction.
This would be easy. Because I kid you not, I sit there and watch, like when my kids are taking tests and they have fractions, they will do this on their paper because this, they can visually see it. I see arrows drawn on it all the time so they don't mess it up. Little kids can do that. Third graders, fourth graders. Yeah, it really would. I don't know. I've never seen anybody draw arrows like I do, like that. I originally got that idea from one of my football players, my first year teaching. He was like, man, when I make my touchdown, I want to do a Des Bryant. And he was like this. And I was thinking about it, I was like, you know, Des Bryant's trying to teach everybody how to add and subtract fractions. They're like, what? He was like, he's just missing this. Then I've had, I think it was last year. Yeah, you should show your little brother that for sure. Now, I think last year the drum majors, part of their march, part of their salute was this.
Yeah, that's right.
Because I actually had the head drum major the year before, and then I had the 2 drum majors the following year. So I had all 3 drum majors. And when I showed that to them, they're like, that's part of our salute. And I don't know if she put it in there, because the one that designed the salute was my student from the year before. Alright guys, no more questions. I'm going to log off. It's been pretty much an hour. My dog is just getting more and more restless. And he's just going to start moving the camera and everything else. So I will be back up if you have any more questions at 5 o'clock tomorrow.
He said it was almost.
Good idea, Renee. Alright guys, see you later. See you tomorrow at 5.